when you, ladies and gentlemen, when you went to enjoy your break, myself and TAs hunkered down to investigate the issue. To recap the issue, which perhaps you remember all too well, what we had is a situation where I had been trying to figure out, we had added a representation of in utero transmission of propensity to become a smoker. And the way we had captured that within person was that basically someone was more likely to initiate smoking if they were exposed in utero. And I ran the model, and I didn't see a big difference within that breakdown of the population. I didn't see a big difference between smokers and non-smokers. We had added these state charts, or these pie charts, and I didn't see a large difference between it. And so I thought, this is really weird. Maybe there's a bug. Maybe there's some problem. So I said, okay, in order to see with clarity if it's working, one thing I could do is basically create a giant impact of in utero exposure and see if that indeed leads for the individuals who are exposed in utero to have massively larger rates of smoking than those who are not. And when you left, I realized I did not see that. I did not see that, ladies and gentlemen. We did not see these big disparities. And I thought, gosh, there's probably some sort of bug. There's probably a bug in here that's preventing this from working properly. And so I started to look as you folks dined. And we located the bug. The bug was located, but the bug lay, and gentlemen, not in silico, but I don't know what you call it, in vivo. In vivo. The bug was in my thinking, not in the model. I'd like to recount there were two aspects of my thinking that were flawed, and I wouldn't have found those aspects without the model to help me. So there's a story here. A story here about how models function to sharpen our thinking. And so I hope you'll excuse me if I add insult to injury of already taking so much of your time with the debugging, but if I further help indicate what was found. Ladies and gentlemen, so what happened is, I said, okay, how can it possibly be? There must be something wrong. We yank up the level of in utero exposure so that those who are exposed in utero have e to the 10th times the hazard rate of those who do not. And we're still seeing lots of people who are uninfected. Lots of people who are never smokers. In both groups. And in both groups, we're seeing still heavy amounts of smokers, with one being not clearly above the other. I said, there's got to be something wrong here. So the first thing that was suggested, and was been on my mind, but I kind of dismissed it internally, but Winchell pressed the case. And Winchell, as usual, is correct. He said, wait a minute, is it possible that what's going on is that the large number of non-tobacco users you're seeing in both is just because both have a lot of kids in it? You're summarizing the whole population among those in utero exposed. That includes a lot of people there's no way they can be smokers yet because they're less than age 11. So he said, basically, is that possible that, and that accorded with my thinking, because I said there's no way that someone can survive even 2 years with the hazard rates of in utero exposure without being a smoker. So my dominant hypothesis was, yes, that's due to kids. But it wasn't until we removed it that we could take the next step. I sort of said, yeah, it's probably due to that, but it was still bothering me. I wasn't sure. So we went and we limited, ladies and gentlemen, those graphs up at the top to display for those 11 and older, who are the ones at risk of becoming smokers. A classic epi issue, right? There's some confounders in your data there. And one of the things I didn't appreciate, but Winchell pointed out, is there may actually be a lot, proportionally more children among those exposed in utero because they die earlier. And so you have fewer individuals of older age, and proportionally speaking, you have more young kids, which boosts the number of individuals who are non-smokers. So that actually ended up downplaying the number of smokers and upplaying the number of never smokers in the population of in utero exposed individuals. So Winchell suggested stripping out it should only report on those who are 11 or more. And that's what I did. And that helped. But still, if I can show it to you, still, we didn't have a night and day difference. So I ran it, and I know you're probably sick of seeing this. Not that again. We did, just so you don't have to see me scroll around, we did actually set up a viewpoint so we could go up there again by Winchell's suggestion. A modest improvement, but one which would have improved your experience. And look what happens. Look what happens. Immediately, once you start having people who can reach this level, you have basically everyone who could become a smoker among those in utero exposed is. And the other still has lots of individuals who are not smokers. But it's still a very, very large group who are smokers here. And as time went on, and you can see it play out in heinous succession, the number of individuals who became smokers for the non-utero exposed was very, very high. And, over time, initially it seemed very clear, yes, it's working, but this was such large numbers, I thought, okay, there's got to be it's probably a problem here. But then, ladies and gentlemen, then it struck me. It dawned on me. Wait a minute. I'm trying to look for this to find a huge difference between this one, which has a very high rate of becoming a smoker due to in utero exposure, with this one which doesn't. But that's not the only rate involved. There's another factor involved as well. I was thinking there'd be a big contrast between the two, but there wasn't. Why? Because of another factor. There's a contagion effect. Individuals who are in utero exposed, yes, they're more likely themselves at a direct level to become smokers, but they also impose a high rate of uptake on those who are not smokers or who are not exposed in utero. So the fact that it's so high here drives much higher rates here. So what I did is I turned off, I basically had a scenario where we had no contagion at all. We had high rates of in utero exposure impact, but there's no contagion between smokers. We turned off contagion, and here we go, we'll go up and look at this. Turn off contagion, and we've got to run it out for a requisite number of years to start making a difference. Here we go, we're about to start. Okay. And big fraction here who are in utero exposed. Among those who are not in utero exposed, a very small fraction end up becoming smokers. Without contagion, these individuals are far less likely to become smokers. These individuals are extremely likely to become smokers because of the in utero effect. So the reason we are seeing such large numbers here was because of contagion, and contagion largely driven by the huge number of individuals who are smokers because of in utero exposure, the very large fraction of those. So ladies and gentlemen, without contagion, this effect is much, much smaller. Now there's a real contrast because they're no longer coupled so directly. They're no longer coupled. These individuals are not persuading these individuals to become smokers. That was a bug in my thinking. I was thinking there'd be a big contrast, but no, it was not as big a contrast because these ones are affected by those. Just like in a randomized controlled trial, some of those who are not as part of the treatment group may have their norms shifted by those who are. Okay, so here we had a giant difference, and that was with giant in utero exposure. And so then we shifted it to a more normal level of in utero exposure impact, and we again saw significant difference between those. So the bug, ladies and gentlemen, was not in the model. It was in two things. It was, number one, I had been sloppy about showing the two populations. I should have ruled out children. I was thinking the proportion of children would be the same between those two groups. It's not. Probably among in utero exposed, they die earlier, and therefore the proportion of children is higher. So Winchell was exactly right. Rule out the confounder in terms of children that are present and that distort those statistics. Secondly, don't think that one group is affected uniquely by a high in utero exposure and the other is not, and there should be a big difference. The other group is affected through contagion. Now, how was I able to track this down? I was able to track it down in large part, a very significant part, by being able to run scenarios with certain effects enabled and certain disabled. I could take a new scenario and I could turn off contagion. Say, now what would it be? I could turn off in utero exposure. Now what would it be? I could turn off births. Now what would it be? That's what a model can allow you to do. And it can sharpen our thinking about how to measure things reliably in the world. If we have these processes in place, is this a reliable indicator? Will this capture the differences between these populations we're interested in, a control and an intervention population? Debugging that in your head is hard. Debugging with a model is easier. And you could see if it's not showing some big differences, why? By turning effects on and off. Why are we seeing these big differences? How much of it is due to contagion? How much of it is due to in utero exposure? How much due to the presence of births? Ladies and gentlemen, I regret dragging you through that, but it's an interesting indication of the versatility of models to investigate these things, the need for basic elimination of confounders from an epi perspective, but also the need to think in terms of nonlinearities like contagion effects when we are examining the effects from these models. And indeed, in as much as those effects are present in the world, to think them through. The exercise is over. The battle won. Your stomachs are full. And my heart is full. Okay. Thank you very much. Okay. Now we will close that chapter.